it's kind of thinning out there as it gets on.
And we're going. I'll grab it on my way out. Just making sure this adjusts. Yeah, thank you.
Okay, everybody. Hope everyone's having a good day. This is going to be a presentation on linking users to social media usage on Android mobile devices. I'll get into what particular device, what operating system of Android we're using a little bit later. But just generically speaking, know that the majority of this should apply to most of the common Android operating systems and use. I'm Ferreira, and I'm with OneSource Discovery. A little bit about me. I've been working in digital forensics for about 5 years now. I got my bachelor's in CIS, or Computer Information Systems, at UofL, in Infosec. Currently working on my master's in digital forensics, doing distance learning at UCF in Singapore, which is a pretty good school for digital forensics. They're consistently ranked top 2, top 3. Also a certified computer examiner. I hold the CCE and the ACE. So one of them is from a non-vendor neutral. The CCE is non-vendor. It's vendor neutral. The ACE is for access data, which is a forensic software provider. Also a certified mobile examiner. I hold the AME, which is the access data mobile examiner. That's for their suite of tools. And LCE, which is for Lantern, like Katana. Forensics is the company that makes that. They specialize in iOS devices. So a brief agenda where we're going to go today. We're going to look at the introduction to mobile and digital forensics. We'll talk about some of the very important key concepts that apply to all digital forensics. Kind of break those down into how they apply to mobile forensics and how they're a little bit different there. We'll get into some specific details about the study and the analysis. We'll talk about, after that, the artifacts that are available. So at that point, we'll get into breaking it down. What sort of information is available when you're logged into an account? What information is available when a user is logged out of an account, but the app is still installed on the device? And then what sort of artifacts are left behind when the user's logged out, the app is completely uninstalled. Lastly, we'll wrap up, and we'll have hopefully some time for Q&A. So the intro to digital and mobile forensics. Whenever we talk about any sort of forensics, one of the key things that is always mentioned is what's known as the low-cards exchange principle. Locard was a scientist who basically theorized that every contact leaves a trace. So you can apply that to forensic science in a traditional sense. If I were to go to a crime scene, I might leave footprints, I might leave fingerprints, there may be some hairs or trace fibers left behind. You can apply the same thing to digital forensics as well. So specifically in the realm of mobile forensics, you think about a phone call. That gets logged on several different places. It's logged on the sender and the recipient's device. And it's also routed on at least one location in between. So it's going to be logged on the carrier's network somewhere. And if you have an instance where you have 2 different carriers that are talking, then you have 2 places. You may also have additional hops in between depending on how far away you are. Facebook messages, it's another thing, same thing, it's going to be on Facebook server, it's going to be on your mobile device, it may even be on a computer, it's going to be on the person's, the recipient's mobile device as well. And then even simply opening an application, there's files on mobile devices that cache when applications were last opened, when they sync with the cloud, or various other timestamps that may occur. So when we're doing any sort of digital forensics, one of the most important things is that you want to do any sort of analysis on a copy, and not on a reading device. There's many reasons for that. The main one, of course, being that you don't want to alter any data on the original, so you want to basically get a copy as soon as possible, work on that copy, and preserve that original. When we get to actual mobile device forensics, the reason why that's more important than traditional computer forensics is tenfold. There's various different ways that data on a mobile device can be changed. It's much more volatile than it is on a computer. These devices are designed to have constant network connectivity and always be up. As a result, you have all sorts of things. You have incoming emails, text messages, phone calls, things like that. But you also have capabilities like remote wiping, remote locking, And data can be very easily overwritten on these mobile devices if that is your intent and you have the tools to do so. And that's even remotely speaking. Passwords are also a lot more difficult, or in some cases impossible to crack on mobile devices. On a computer, if anyone in here has ever tried to crack a password, you pull some files out of the registry, you can kind of try and build some dictionaries and run those against the computer's databases, and you pretty much have a finite amount of time because you can pull those outside of the computer. While the mobile device, you a lot of times have to actually crack the password on that device. These have timeout periods. Some of them have security protocols that will actually wipe the device. So that can be more of a pain on a mobile device. Also, encryption is becoming a default standard in on mobile devices, not necessarily an option. Apple's been doing this for some time now. They have their iOS is automatically encrypted. Android recently announced that their newest version is going to have encryption by default, which a lot of law enforcement is up in arms against. They think that everyone is trying to, by encrypting it, we're helping criminals. They don't understand that we're actually trying to save people who are innocent, and the majority of people in the world that are going to be using encryption are going to be innocent. The other principles for mobile device collections, it's important to know every single step for a mobile device collection before you go through it. You need to have it backwards and forwards in your mind that when you run through, because these devices are so volatile, there's not any room to stop, go pull a textbook, look up what you need to do next. What is this error code exactly? You need to know exactly what you're going to get, because all it takes is 1 second that phone is connected to the network, and your data could be gone. It's also important to know the outcome to any choices that you're going to be making. So basically you want to make some sort of tree when you're going into it. Basically say, if I choose this, then this. If encryption is enabled, then what are my options? If this type of password is enabled, what are my options? That can help along the process. And lastly, everything should be documented. This applies for all the digital forensics, but I want to mention this especially for mobile device forensics too. So some of the solutions that are available for mobile device forensics, this is in no way an exhaustive list, and I'm not playing any favorites here. This is strictly alphabetical. There are some here that are open source, and there are some here that are proprietary. Some are very in-depth, and some are very low-tech. So we'll go through some of the examples here, and I'll show you some pictures of them, kind of explain what they look like, what exactly they mean, and some of the advantages and disadvantages of them. First one we'll talk about is the lowest tech that you can get. It's called projector phone. It's exactly what it looks like. You've got a digital camera on top there, and you have a C-clamp of some sort, and you basically just scroll through everything on the device and record it as you're doing it. It's great in that it supports every single phone on the market. And that's their marketing focus. They say, we support 100% of phones. They do, they're not lying. The downside is you're limited to what you can get off of it, obviously. When you're scrolling through, you're going to see exactly what the user sees. So you're only going to see active data. You're generally not going to see anything deleted. You're not going to see anything that's been cleared out to free space that you would get with some of the more robust tools. Another tool that's available is BitPin. This is kind of an older tool. This was originally made for CDMA phones. So a lot of times we would use these back when the flip phones were very popular. Once the iPhone came out, it kind of made this a little bit useless. But you can still use it on some flip phones, and some of the newer phones still support it a little bit too. This is an open source tool, and it's good in that it supports a decent amount of tools, or a decent amount of devices back then. But one of the downsides, you'll notice up here, is that there's a phone with an arrow pointing to the right, and then there's a phone with an arrow pointing into the phone. This tool is read-write, and that's a big problem. A lot of law enforcement that didn't know what they were doing actually lost a lot of cases using this sort of tool. Because the problem is, when you read in data, it reads it into one folder, and it's all the same folder. So you have every case, and it basically just overwrites whatever data you have. As you're reading it out, see where the problem could come in. You could read out a text message database for your last case, and that gets written to your new case, and now all your data is gone before you had a chance to collect it. One of the tools that is proprietary in nature is the Celebrate UFID. It's the Universal Forensic Extraction Device. This is actually the one that I primarily used for this analysis. It's a very robust tool. In the mobile forensics world, for the most part, you get what you pay for it. There are some exceptions to that. There are some open source platforms that are actually pretty decent. But these guys have the added benefit of partnership with a lot of mobile device providers. So anytime that you go to Verizon, you go to Sprint, anywhere like that, and you get your contacts transferred over from one device to the other, they actually use a dumbed down version of this UFID here to do that. These guys have a partnership with all of the mobile device providers, and as a result, they get mobile phones 3 or 4 weeks before they hit the market, because they have to have support for them in their code. Upside for forensic examiners, we get support the day the device hits the market. So that's great for us, and it's worth its weight in gold. The other added benefit to this, you can get full dumps of the device. You can get all the deleted data. You get basically a full data dump of 16 data entering device. You're going to get a 16 data raw image pop in. And then you can run scripts against it. This is actually really good because they have some auto parsing tools that they have, and then they also have the ability to write Python scripts. They have a hex viewer in it, so you can go into that. And you can see here, there's actually a script that was ran to find out the lock password of this device. So that can be really useful too. If you have a device, you can actually use this program, get a bootloader, which is basically a customized ROM for that device. And it'll allow you to bypass the lock temporarily, read it in full image. You then rip through it for that password, and then you can then turn the device on, punch in the passcode, and unlock it and do whatever else you want to it. It's a really useful tool. Some other tools available. This is what's known as JTAG. Basically, it's the Joint Test Action Group, is what it stands for. But what it basically is dismantling a phone, and then you actually solder these leads here onto various leads for the data ports, for the on-device chips. And then you read that off. This one is made by PhoneFun. This is a RIF box. This is a pretty common one here. They're basically made originally to test phones in the manufacturer's warehouse before they get sent out. And people have now started buying these and applying these to get sold on phones. Another option that's available is what's known as chip off. Basically, it's simple as it seems. You take the chip off of the device, and then you manually read it using some sort of manual chip reader that's going to plug into each one of those pins and sockets and get that data off. It allows for a full data dump, which is really useful. It also supports most phones, really, because you're just reading ones and zeros. The downside is, of course, once you get that dump of all the data, you then have to parse it, you have to analyze it, and that can be a very tedious task. So this and JTAG are two of the very labor-intensive, upper-tier programs that are available, or methodologies that are available. There's actually only a handful of places in the United States that are not law enforcement that even have the capabilities to do this, much less to do it. So it's pretty good technology if you get hands on it. But obviously there's a lot of skill involved in learning that. So what sort of data is available from mobile devices? Well, I mean, obviously you're going to have your contacts, you're going to have your text messages, your call logs, things like that. Some of the lesser known things, emails, a lot of times those actually get pulled down, cached to the device, and sometimes they're stored there for a week, sometimes they're stored there indefinitely, basically, until they're overwritten. So that can be something you do from mobile device analysis. Internet activity, a lot of people use their mobile phones on the go. Personally, I pull my laptop out only when I need to. Otherwise, if I have something I'm going to Google, I usually do it on my cell phone. But a lot of people are the same. Voicemails is a big one that always surprises people. Various devices out there will actually pull down the voicemails from the network provider that can cache a localized copy on there. We've got iPhones are notoriously bad for this. We've seen several iPhones with a couple hundred voicemails, and you can listen to it in its entirety. It's just sit there on the phone. Messages that were deleted months and months or a year or two back, and we can tell you what time it came in, who left it, and listen to the entire thing. Documents, obviously, these are on the go. They all have Office plugins. GPS coordinates and wireless networks kind of go hand in hand. Those can give you a pretty good idea of where someone's been going and what they're doing. But most important for us, and what we're going to focus on today, is application data. So what sort of statistics can we get? What sort of information can we get out of analyzing applications on the device? So why app usage? Well, there's over 1 million apps in each respective store. Obviously, that's a lot to keep up with, and they push out updates fairly regularly. You're looking at maybe getting an update possibly once a month, maybe even more. So it's a pretty burdensome task for all the software providers out there to keep up with the apps and make sure that the newest version of Facebook is fully supported and the version of Facebook that's 2 years old is fully supported. Pretty laborious task, so it's an important skill to know in the mobile forensics world. Why are we specifically talking about social media apps, and why these social media apps? Well, there were some Pew studies, Pew Research Center did some studies in 2012 and 2013. They have some for 2014, but they're not quite as robust and built out as these are. So basically they found that of online adults, so anyone 18 and older, 71% of those people use Facebook. That is a huge number of people using Facebook. And so if you think about how many people on a mobile device nowadays, and how many people on a smartphone nowadays, what sort of demand they have on the market, then it doesn't take very long to add up the numbers and find out that there is a huge user base of Facebook mobile device users. They also found that 22% of those online adults use LinkedIn, 18% use Twitter, and 6% use Tumblr. As far as application popularity goes, these are the actual mobile device versions, so they're counterparts, and these are the stats associated with them. So as of August of 2014, this is directly from the Play Store, Facebook is ranked #1 in the top 3 social apps and #2 in the top 3 apps, period. 500 million plus downloads. So that means that there are 500 million plus, and they don't keep statistics higher than that, mobile devices sitting out there in the world with Facebook on. Twitter is ranked #4 in top 3 social, 14 in top 3, 100 million downloads. LinkedIn ranked #10 in top 3 social, 117th in top 3, but I mean, there's a lot of really fun things out there, guys. You don't want to network all the time. But they've still got a pretty substantial user base, 10 million plus downloads. The reason for the drop in the download here, based on the study, appears to be, from what I can tell, that you generally find an older user base for LinkedIn, and those people are less likely to be on their mobile devices every single day of their day. And so they're going to probably network on the computer. But your younger base is going to choose their mobile device most of the time, and that's where a lot of the growth for LinkedIn comes in. Tumblr is #11 in the top 3 social, 121 in top 3. Not so great again in top 3, but as a social app, still pretty reputable. 10 million plus downloads. So some information about the study. The specific information that this comes from is from the Samsung Galaxy S3. It was running Android OS 4.3, which is Jelly Bean. I know some of you are saying, well, wait a minute, it's an old OS. Well, it is technically, but the way that Android is put together, there's a lot of fragmentation in Android. Basically, when a new operating system comes out, Google pushes it out right away, but then it goes to the network providers, it has to go to Motorola, it has to go to Samsung. They all do a bunch of testing, and at some point they just start excluding devices and say this device is never going to get upgraded anymore. So based on that, you can see that even though KitKat is the newest operating system out, it actually commands less than 25% of the Android market in use. Jelly Bean, on the other hand, has about 55 or so percent of the market that they command. So this is still a pretty relevant operating system for something that's a year and a half, 2 years old. The tools utilized here, as I mentioned, UFED Physical Analyzer, did that for both the collection and the analysis. SQLite Expert Personal and SQLite Database Browser. Both of those are open source, or sorry, not open source, but open license, so you can actually go and get those and play around with those if you want. They basically make the SQLite tables a lot prettier. And MFT Stampede, which is pretty good tool, also a free tool out there that I'll basically use for some of the timestamps in here. A lot of the timestamps are generated in Unix epoch time, which is the number of seconds since January 1st, 1970. Obviously, I don't want to count that long, so just go ahead and use a tool like this and put that information in. Application versions specifically, these are not old applications. I want you to keep in mind that everything that I've done here is done in May, June, July. So a lot of this analysis is on pretty relevant applications. Some of these may only have 1 or 2 updates since then. But like I said, we're going to discuss Facebook, LinkedIn, Twitter, Tumblr. I'm going to try and keep them in that order as we're going through each of the 3 subsets. Sometimes the line's been kind of gray, but I'm going to try to stick to that order. So now we're going to get to the more technical part of it. If anybody has any questions along the way, I don't want to leave you behind. At the same time, if you have something that you're just kind of curious about, I'll ask that you leave it to the end. But again, I don't want to leave anybody behind, so please speak up if you're lost. So we're going to talk about the apps that are installed and what sort of information is available from those when accounts are still linked. Well, generally speaking, these apps are social media apps. So what are they going to let us do? They're going to let us look at the user account information, of course. The user account we're linking to. So you might get some information like a URL. If you have a phone number running on your account, that a lot of times is cached on the device. Any sort of information like that. But also posts that those people have made, both on their walls and to other people's walls. Who they follow. Who may follow them, so this is in the case of Twitter, Tumblr, and then also their friend list. So for the user accounts, these are kind of blurred a little bit, but they're pulled from several different locations. A lot of this information that you're going to see here is pulled from SQLite databases, which is basically the mobile counterpart of SQL. The majority of the stuff, until we start getting to when the accounts are uninstalled, or unlinked, and when the apps are uninstalled. The majority of the stuff is going to be available from those SQLite databases, and they're just directly in the group that belongs to that application. So they're actually really easy to get, provided you can get that dump off the device. But if we look here, we see all sorts of information. So if we look at Twitter here, you can see that the account name is Ryan F. Here's a little profile picture that it's going to give me here, the username for LinkedIn, information here, even the phone number for it. This is the Facebook table here, so you see it actually gives the Facebook username, which in this case is the email address that's used. It gives you the last login time. That's in that Unix epoch. And it gives you information about, in this little row right here, FB_me_user. So this is all sorts of information about the current user. So you'll see last name Ferreira, first name Ryan, there's my email address, phone number, all sorts of good stuff. Tumblr is pretty similar. You get the name, you get the URL, where the actual account is located at. This value is generally going to be 1. That means it's the primary account on that mobile device, so it's your account basically where you're logged in as. How many posts that you've made, all sorts of information like that. So we can take this information that's here, and at this point in its raw form, it's pretty easy to connect information to a user. Obviously, if you're seeing someone's first and last name, that's usually a pretty dead ringer. But there are multiple people in the world named Ryan Ferreira, so I'll give you a little bit of doubt. But if I take this URL right here that's listed as PicSquare, and I drop it into a Google browser, what I find here is a thumbnail of my Facebook profile picture. Similarly with Twitter, you can take that same profile picture, drop it in, find that. Same thing with LinkedIn, drop it in, find the profile picture there. Postmate, you have to dig in a little bit to get these sometimes. In this case, I had actually dig out a hex viewer and do some searching on these, but you can see here, there's a post right there, and there's another post right there, and you can even see down here, so-and-so likes your comment, and that information is cached, and there's various date and timestamps that are within that. You can actually pull out using an NFT stampede. You just kind of have to know what the patterns look for, what are Unix epoch timestamps supposed to look like. Who the user follows or who they're followed by. So you can see here, this is just a database from Twitter. You get their Twitter handle, you get the type. So in this case, all these people are someone who I'm following. You get their URL, and there's even a nice little link out to their page as well, their profile page. On Tumblr, if you open up their SQLite table, there's actually or SQLite database, there's two tables in there, followers and following. So you can look at each one of those and find out what the respective categories are. And then once you've got that, you'll see the username, the URL. This primary is going to be null because, as I mentioned, these are not the accounts that are logged in, not the main account. And then they may have some information about it, like the title of their page. These right here are those Unix timestamps. I don't know if you guys in the back can see them or not, but you'll see the last modified time. They generally start with like 14, 13, and it's going to be a long string of numbers. It's like maybe 12 numbers. Friends lists. LinkedIn, you call up in their SQLite database and you'll see a connection table here. That connection table is going to give you all sorts of information about them. You're going to get all the display names, first and last name, their headline, which for LinkedIn is generally going to be what their profession is, and then a picture URL, and there's other various information stored in there as well. And then down here, this is a screenshot of the Facebook SQLite database. So you see you get the same thing, their Facebook ID, which we'll talk about a little bit later, the first and last name of that person. You have a huge picture URL. They also have like a small picture URL, various sizes between. I think there's a medium also. So even if one of those records happen to be wiped out, you can look at the other one and see a version of that. And then they also give you information like when you've added this person as a profile or as a friend, and they also have a communication link. So they actually keep statistics on how often you talk to someone. So if you're in any sort of legal matter, you can look and see, okay, well, see that you talk to this person, your communication rank is 3.4, and this person is 0.03. So I want to see some information about that person that's 3.4. Probably don't care about this person that's 0.03 because you may have talked to them once, I think. Some of the information about when an app is installed that the user's been logged out. At this point, we'll get a little bit more into the Hex viewer type information. So if anybody's squeamish about Hex, don't worry, hold your hand, get you through it. But there's also some information here that you don't even have to dive into the Hex viewer. You can see. So as we're logging out of these apps, pretty standard. Facebook's logging out and signing out. Then we notice for Tumblr, clearing out your data. It's pretty nice. Thanks, Tumblr. Twitter, signing out will remove your Twitter data from this device. Do you want to sign out? Sure. Yeah. Take care of my evidence. Get rid of it. As everybody in here should probably know by now, your data is not gone when it's deleted. And as there's been numerous studies that have come out recently by various, Avast was one of them, various organizations that bought phones on eBay and just ripped all the info off of them. You guys know that this isn't actually the case. So we originally think, okay, Twitter, Tumblr, you guys are being great. You're taking care of all of our sensitive information. I can take this phone and do whatever I want, and then I don't have to worry about any sort of identity information getting out there. But we all know that it doesn't really get deleted. Facebook, they just make it too easy for us. You open up the application, they've actually cached your streaming right there. So if you've got someone that just logged out real quick, it doesn't take very long. Just pull up the phone and look at that. But there's actually databases that keep track of all this information. So one of the Facebook SQLite databases keeps track of the last username. So I can safely say that the person with this email address was the last person that was logged into Facebook on this mobile device. I can also see the last logout time, which is sort of Unix epoch, and I've got it converted there using MFT Stampede. But if you have someone who, right before giving your device, they go ahead and they think, I'm going to be sneaky, I'm going to log out. Not only do you see the last username, but then you can say, well, 30 seconds before I got your phone, I see a timestamp here that says that you logged out. That's a little fishy. And judges are going to respond pretty favorably for you in that sort of scenario. LinkedIn, at first glance, you think we're going to be good. If you're in that LinkedIn database there and you're looking at the connections tab, you're looking at the profile table, there's no information there. And that's good. They're doing what they should be doing. They're taking their information out of there. But unfortunately, that's not fully the case. There are other databases that are that kind of work with this. There are some backup databases and things of that nature. So if you open up this particular database, what you'll find is the current user, which is actually not the current user because we know that someone's logged out, but it's LinkedIn's way of saying this is the last person that I've interacted with. And when we look at this, we find that everything is pretty standard on this, just like we showed earlier. So you've got your profile picture here that you can pull out, drop it into any sort of browser, and find it directly. There's also this number right here, the ID. And what that basically is a unique member ID that LinkedIn keeps track of whenever you join. And there's a particular formula for that. So you can basically take this URL here, ID equals member ID, drop that into a browser, and then it takes you directly to their full page. So not only are you just looking at a profile picture, now you're actually looking at all their information and finding out, okay, well, this isn't just a person who looks like you, or maybe you have a picture of a cat for your profile picture for whatever odd reason. But now I see, your name, and there's your profession, and here's where you live and work. Some of the more laborious things to get into, what sort of website URLs for various other people, so for your connections. Member IDs for your connections, and also timestamps of activity. So keep track of when you may have last talked to someone, written something on their wall, or possibly even when you may have messaged them, or excuse me, not messaged them, added them as a connection on LinkedIn. And so you can see here, if you know what to look for with the patterns, there are various key terms that you can search for within the hex, and you can actually go and based on those just kind of read through. A lot of times these are just stored like just simple XML tables. They're just moved into free space. And so you can take this information and you see a URL for this user right here, Ernie blanked out name, where he works specifically. He's a director there. He's a VP director actually. And his ID, so we can jump directly to his profile too if we want. And then there's some timestamp information here for this user as well. Twitter. Twitter makes it pretty easy on us. This is that Twitter database here. What they actually have is databases underneath their directory. One of the databases that's created as soon as you log in is basically your Twitter username. That's a unique user ID. It's a numerical number, numerical value. And you can do the same thing with that you can do with LinkedIn. So you can take that number, you can punch it into a similar formula here, user ID equals Twitter ID, take you directly there. There's also another website that I actually found during this analysis I wasn't even aware of, that just makes it all too easy, tweeterid.com, and you can basically drop a unique ID, and then you can get someone's name, their Twitter handle. You can also work it the other way too, so you can drop their handle, and you can know what that is. Get their ID, and then you can then search for that ID on the device. There's also some activity timestamps with Twitter once you've been logged out. So there's a preferences XML file, and you'll see here that for the map specifically, they keep track of the timestamp for this user, for the last time that this map feature has been activated. Tumblr, I mentioned. They're going through and they're clearing out your data, and I want to point out that they did clear out your data here. You'll notice that the record stops at number 10. There is no number 11, which is where my record was in that table. But I can take this information and I can search for any of these users. I chose this one in particular. And there's that user right there. And there's this person. All you have to do is run through this list here if you really want to. And just basically cross off every single person that's still on the list. And the person that's not on the list, there's a pretty good chance that that's going to be the person that was logged in. There's also a way to go and find the email account. Again, email accounts don't necessarily equate to a person, but they give you a little bit of cause there. So if you know specifically what to search for, there's databases completely outside of Twitter and Facebook's hands altogether. So there's actually a contacts database that Android keeps track of. And so they don't have permissions to go in there and get any of that information. They basically they send a query out to a contact database to wipes out that information to free space. So then you can search for Tumblr account, and here's your Tumblr account. Now, once the apps are uninstalled, this is a pretty laborious one, but there's still some good information that can get there. Most of this is going to be required from a hex viewer. So the first thing that we want to know is, well, how do we know that something is actually uninstalled? Obviously, if you don't see the icon for Facebook, if you don't see it for LinkedIn, how can you even say that it's ever on the device? Well, there's several different ways to try and figure that out. So if you look for APK files, which are basically the Android package files, those will be on the device. We'll see here that they're flagged as deleted, but again, things are deleted, they're not really gone. You can also see here, if you look at the actual directory structure, the Facebook, com.facebook.katana, com.linkedin.android, com.tumblr.twitter.android, those are still existent under the data folder. They just have little red X's next to them. Basically means these are deleted folders and don't write any more data here. But we've actually found that these persist for a very long time. And I've seen many cases where they persisted for the entire client's life. And you can also look at usage statistics. There's various XML tables that are on mobile devices that keep track of when the last time was that you opened a device or opened an application, how often you use that application, basically to try and cache that or have it readily available. If you're a very heavy Facebook user, your phone's going to try and do a little bit to get you Facebook faster than everything else. So there's some good artifacts there usually. And lastly, image carving is another good way. You can do carving for basically across the entire device for JPEGs, PNGs, whatever you choose. And then you basically just go through the task of scrolling through those. And when you find a decent amount of pictures that are associated with LinkedIn, maybe you find the LinkedIn logo 10 times, LinkedIn was probably installed on that device. And that gives you a little bit of something to start digging into, the starting point, if you will. I mentioned the user accounts, that useraccounts.db, or the contacts2.db database. So once all these have actually been cleared out, and once all these have actually been uninstalled, you can still go to that database, and if you view it in its raw format, everything is basically just sitting there in free space. So I've gone through and basically highlighted each one of the accounts. You can see, here's this account, Ferreira_test for Twitter. You've got Ferreira.testing@gmail for Tumblr. Here's the email address for the LinkedIn. There's the email address for Facebook. Same thing over here. This is just a different location on the device, actually. So there's generally going to be multiple locations that are going to cache this sort of information. We can take some of that information. There's, again, magic keywords that you can search on to find things. So we look for this token owner. So that's the owner of a Facebook account on this device. And we get a string here that's in the unique user ID for Facebook. And there's actually, they make this super simple. You don't have the user ID equals. It's just Facebook / whatever the person's user ID is. And you got the profile right there. And then you've also got the Facebook link to their URL right here that you can just drop in to show their profile picture. You also get things like their full name, their email address, even their phone number all still persists. So these are all things that can be utilized. All of these in conjunction, you can say, okay, well, there may be multiple people in the world named Ryan Ferreira, and your name does not necessarily mean that you have that email address, but this is your mobile phone number. This is a picture of you on your profile. LinkedIn, it's a very similar process. once you know what to look for, this member ID value is really good and special one that you're looking for. And then once you find that, you just take that, drop it straight in, and you'll see a URL up here, account name, so the email address associated with that. You still have the profession there, and if you dig a little bit further down, you'll see like all the other information that's going to be on the main page, so where they get their education, who they associate with, things like that. Tumblr, again, makes it fairly straightforward. Use your Tumblr name, rhymtesting.tumblr.com. Twitter, same thing again. Go to this accounts.db folder. There's actually multiple folders across the Android device too, so it makes it that much harder on the applications themselves to go in and wipe out information because there are multiple storage locations. But if you know what to search for, so this com.twitter.android, that's going to give you a ton of hits if you search that on a hex dump with a public device with Twitter on it. But if you have this little .oauth.token, then that takes you to their username, their user ID rather. Just kind of in summation, and wrapping up, I always hope that presentations, if they're a little over your head, they basically make you want to go and look into it a little bit more. If they're not over your head and you understand them, I hope that they inspire you to just look into it. So a couple areas for future research, if anybody out there just gets curious and wants to look into it. Like I said, there are plenty of open source options out there, and some of them are pretty decent. Various other apps, like I said, there's over 1 million per store. So here's 4. So 1 million plus minus 4, or 2 million plus minus 4 rather. BlackBerry devices, obviously they have an entirely different architecture, different way of storing things and deleting things. iOS devices also entirely different way that they store everything and handle deletion. Windows phones are the same. So with that, thank you guys for your time. If you have any questions, if you have any more wisdom, that's never a good sign.
Well, I guess you've shown us how to find the data. Are there any apps that you know of that delete data? In a good, effective way. Which admittedly is not necessarily what you like, but
yeah,
from maybe personally you might want privacy.
Yeah, the best things that I can think of, any sort of really good like mobile device management applications that are basically going to containerize everything in that. That gives them a lot more flexibility and control over what the data is. And so then they can actually go in, your admins can go in and actually wipe out that container. So those are usually pretty good. Another technique that I've heard which works for some things but doesn't work for some of the other things that are protected by the user databases, basically just copy a bunch of data over to your device, like plug it in like a thumb drive, copy 14, 15 gigs worth of pictures to a 16 gig device, and that's going to wipe out it. But that doesn't get a lot of it out. I would probably say your best solution is going to be some sort of really good MDM software. That or factory resets aren't that great.
That's kind of what I was asking. I mean, most people factory reset. Does it really clean all the data?
Hammers work really good. Hammers work really well. But only if you actually take out the board and are breaking the chips. The only phone that I've really seen, there's Tailnet, the BlackBerry is like, and this is why the government had contracts with them.
Yeah.
Factory reset wipes everything out. I've seen a couple that wasn't the case. So that myth for me is debunked. iOS devices are pretty good because the way that they work around it, and this is how the new Android devices will probably work. Everything on an iPhone is encrypted, and basically they're using 256 AES. And what happens is when you factory reset, the keys get deleted. Mm-hmm. So all your data is still there, but you're never going to get it.
Yeah.
So they actually stopped. They used to have the functionality to get a full data dump from an iPhone. They actually stopped working on it because there became a point where it was just useless, like you weren't going to recover deleted information. You know, if there was, you know, a deleted video or a picture, it's, you know, almost as good as gone. You might find some records associated with it, but there's no point in getting a full dump because it's going to be encrypted data. All right. Thank you very much.
There, it's sandbox into you'll have some. You can, yeah. It doesn't need directory. So,
So I'm sitting here using my phone. Have you looked at things like Evernote or things like that that just store volumes of data that it syncs?
I haven't actually looked at any of those in particular, but I know that a lot of those do keep a pretty robust cache of data on.
Right, that's kind of what I was like. Yeah, because there's a lot of people use those too. So
yeah, as far as what actually happens to that when it's been deleted, I can't say for sure.
Yeah, it
I
is.
have seen it when they're actually installed.
That's why I don't use my Nexus for
I mean,
anything.
it's
it's installed and you can seal almost all the data.
Yeah.
Because that makes the whole point of caching, especially when you're using it offline or don't want to be activity.
right, and it's treated no different than anything else either. So you know they do pull it all down during when you get that full data.
Off the top line.
You're going to get that included in that dump. You just need to know where to look for it, how to strip it out.
I guess that means you guys don't really have a good way to get data dumps out of iOS. The newer version.
You don't get you get a data dump. It's you don't get what's known as a raw data dump. So you don't get a full image of the device, but you can still dump out all the data. And a lot of that, you know, the containerization principle, you know, in a database kind of holds for those. So if you're looking at like text messages, for instance, a lot of your deleted information is going to stay there basically until it's set to clean that out. And a lot of times that doesn't ever happen.
Yeah.
So, because I know a lot of the, even on some of the older iPhones, they had the functionality for it. And if you turned it on, then you could use it in some of those devices. And sometimes even the deleted messages on there are still able to pull those out. There's still some options for iOS. They're not completely done. If somebody goes and mass deletes like all their pictures, we're probably not going to get them. But if they've got, you know, some text messages or iMessage or things of that nature, then there's usually still this kind of there.
Because yeah, the phone stuff kind of, it's one of those things that just kind of cropped up, and it's like all the normal forensic tools don't work per se. So it's kind of like, okay, crap. Now what do we do?
Yeah. Well, a lot of them are actually trying to build in support for this.
Like, I know they are now, but I mean, it's like that's more something that started to happen like in the last 2 to 3 years of that, and even then they're kind of sketchy.
Yeah.
Per se. So
When I started out, the first things that I was doing were in Bitman. And we pretty much like we had that, and I remember there were several cases that I worked with where it was basically just looked at the information that was on the phone, like just hold on.
yeah. I mean, I do know that the local FBI forensics, they do. Have you used any of the like mesh?
Faraday bags?
Yeah. Is that sort of to keep the data from? Is that something that you still use effectively?
It's, yeah, the whole idea is to keep it off the network.
Right.
The downside is that as these devices get better and better in their technology and network connectivity, If you look at some of the older technology, older Ferreira bags, if you have a bag that's like 2 or 3 years old, it's pretty much considered obsolete. Most of the antennas now use Apple stock right now. So like they're constantly coming out with newer versions of Ferreira bags with thicker shields, triple, quadruple layer shields. Just because, you know, there's still some information that's getting out. I've seen several of them that they're somewhat good enough, and they'll take out all your data connection. And so you won't have 3G, you won't even have like your 1X connection. But you'll have like one little bar left for, you know, which is all it really takes. It's just enough to get, you know, a text message or a phone call that could push something off the end of the database.
It's just like, come on, just put it on the browser.
Yeah, I think we're coming to that point. Interesting.
Cool. Now the tool you were using, the collage, or
Celebrate?
Yeah. We're using that for just phones, or is it to other data image?
Their primary market is for mobile devices. They also work on GPSs, so you can get data dumps from, you know, all the various GPS models. But yeah, their primary market is going to be cell phones.
Okay.
And then tablets.
You stop done?
Yeah.
Okay, this is in recording, by the way, with the last. Y'all didn't say anything, right?
No. It's just generic good questions.
Okay, thank you.